class. All right, so this will be my final presentation on Chapter 7 Formulas and Calculations, CVP Analysis, Cost, Volume, and Profit. Still working on problem 39A. So I will show you how to calculate operating leverage, which is number 7 and 8 within 39A. Then we will consider some changing circumstances. That's number 6. And finally, break even when we have a situation where there is a second product line. First up, operating leverage. So the formula for operating leverage is the total contribution margin divided by operating income. This is a very useful tool because once we have this factor, we can calculate, estimate, if sales go up by 10%, by what amount will operating income go up? So this is a very useful tool. And I've said this before, I will repeat. In terms of the test, I recommend that you have your formulas written there for you so you can quickly go through these calculations. Okay, so let's do the math. Contribution margin. So we know that our contribution margin is $2.50. So we're going to take $2.50 times the 130,000 units that they have projected to sell in this problem. That gives us a contribution margin of $325,000. And we need to divide that by operating income. And operating income is the contribution margin, $325,000, less our fixed costs, $290,100. So our our operating income, $34,900. And so the percentage, 325 divided by 34.9. So I'm going to say approximately 9%. 9.31 actually, rounded. Okay, so that's the answer to number 7. That's the operating leverage factor. Number 8, we are told, well, if sales go up by, and let's see, what is the percent? If sales volume increases by 7%, by what percentage will operating income increase? All right, well, we have what we need. 7% times 9.31. So basically, we do the math here, 65.2%. So again, if sales go up by 7%, and we already have our operating leverage factor, operating income will go up by 65%, which is very nice. Obviously, they're covering their fixed costs. So now all the sales that they're making are very profitable. So that's the answer to 7 and 8. Let's go back then to number 6. Number 6, we have some changing circumstances. They tell us in the problem for number 6 that management is in contract negotiations with the labor union. And if the negotiations fail, direct labor costs will increase by 10%, and fixed costs will increase by $22,500. If these costs increase, what will the company have to sell in order to break even? Okay, so we're going to go back and do our break-even calculation. So I'm going to erase this, and we're going to have a new break-even calculation with these changing circumstances. So I'll put the 22.5 here. Okay, so We know that the contribution right now, the contribution margin currently is $2.50. If labor costs go up by 10%, 10% of $7 is 70 cents. That means the contribution margin will go down by 70 cents. So that gives us $1.80 for our new contribution margin. So remember, that's below $1.80. Our fixed costs, they tell us, will go up. So we're going to add 22,500 plus 290,100. So our new fixed cost number will be $312,600. So the new break even will be that amount divided by $1.80. So the new break-even units, 173,667. If you remember, it was around 116,000 units before. So this has been a very costly change between the original 116,000 and now this. So this, my friends, is the answer to number 6. Okay, last up. We're going to go back to the original information. So I'm going to erase this and this. And we are going to be given a second line. So I'm going to summarize this. This is our first line. We have $20 here. We have variable costs here, so $2.50. And I'm going to now finally erase all of this. So we're told that there is a second line, and the selling price for the second line is $45. And by the way, this could be done, this is a wonderful thing to do in Excel. We could do this with many products, and we're just going to do it manually with 2. So the second line upgraded is $45, and the variable costs for that line are $28. So the contribution margin for that second line of products will be $17. So they tell us for every one of these, they sell 6 of these. And what we need to do at this point is calculate a weighted average contribution margin. All right, so we're going to sell 6 of these for 1 of these. So that's going to give us 17, obviously, and 250 times 6, 6 times 2.5, 15. So to calculate our weighted average, we're going to have the 15 plus the 17. That's going to give us, let me make sure I did the math right, 15 plus 17 is 32 divided by 6 and 1, 7. So our weighted average contribution margin is 32 divided by 7, $4.57, which I believe they round to $5 in the problem. Okay, so now we're going to go back and use our fixed costs because they want to know how many of these they need to sell to earn that profit that they had talked about. So first of all, let's get our fixed costs. So the fixed costs are 102,300 plus 187,800, and they still wanted to earn that profit they talked about of 260,100. So here's our top number, our fixed cost plus our desired profit. So 102,300 plus 187,800 plus 260,100. So our top number is 550,200. The weighted average contribution margin is 5. So what does that give us? We know at this point that we need to sell 110,040 units. Now, last part. So we now know that we need to sell this many units. We're going to figure out how many of each. Well, this part, the math is pretty easy. I will erase this. Remember, it's one of these to 6 of these. So if we take 110,000 units and divide that by 7, get rid of all of this, 110,040. We know the new expensive ones. We're going to divide this by 7. We're going to need to sell 15,720 of those, which means we're going to need to sell the difference, 110,040, 94,320 of our original units. So this is our weighted average calculation. And here is our final answer. 110,040 units, 15,000 of our new expensive product, and 94,000 of our original product. And that brings us to the end, at last, of problem 39. So I hope you all stay well and safe, and that is the end of chapter 7. Have a great day.